A mountain range is a geographic area containing numerous geologically related mountains. A mountain system, a system of mountain ranges, sometimes is used to combine several geological features that are geographically related. On Earth, most significant mountain ranges are the result of plate tectonics, though mountain ranges are formed by a range of processes, are found on many planetary mass objects in the solar system and are likely a feature of most terrestrial planets. Mountain ranges are usually segmented by highlands or mountain passes and valleys. Individual mountains within the same mountain range do not necessarily have the same geologic structure or petrology. They may be a mix of different orogenic expressions and terrains, for example thrust sheets, uplifted blocks, fold mountains, and volcanic landforms resulting in a variety of rock types. Major ranges. Most geologically young mountain ranges on the Earth's land surface are associated with either the Pacific Ring of Fire or the Alpine Belt. The Pacific Ring of Fire includes the Andes of South America, extends through the North American Cordillera along the Pacific coast, the Aleutian Range, on through Kamchatka, Japan, Taiwan, the Philippines, Papua New Guinea, to New Zealand. The Andes is 7,000 kilometers long and is often considered the world's longest mountain system. The Alpine Belt includes Indonesia and Southeast Asia through the Himalaya and ends in the Alps, Spain and Atlas Mountains. The belt also includes other European and Asian mountain ranges. The Himalayas contain the highest mountains in the world, including Mount Everest, which is 8,848 meters high and traverses the border between China and Nepal. Mountain ranges outside of these two systems include the Arctic Cordillera, the Urals, the Appalachians, the Scandinavian Mountains, the Altai Mountains and the Hejaz Mountains. If the definition of a mountain range is stretched to include underwater mountains, then the ocean ridges form the longest continuous mountain system on Earth, with a length of 65,000 kilometers. Divisions and categories. The mountain systems of the Earth are characterized by a tree structure, where mountain ranges can contain subranges. The subrange relationship is often expressed as a parent-child relationship. For example, the White Mountains of New Hampshire and the Blue Ridge Mountains are subranges of the Appalachian Mountains. Equivalently, the Appalachians are the parent of the White Mountains and Blue Ridge Mountains, and the White Mountains and the Blue Ridge Mountains are children of the Appalachians. The parent-child expression extends to the subranges themselves. The Sandwich Range and the Presidential Range are children of the White Mountains, while the Presidential Range is parent to the Northern Presidential Range and Southern Presidential Range. Climate. The position of mountains influences climate, such as rain or snow. When air masses move up and over mountains, the air cools, producing orographic precipitation. As the air descends on the leeward side, it warms again and is dry, having been stripped of much of its moisture. Often, a rain shadow will affect the leeward side of a range. Erosion. Mountain ranges are constantly subjected to erosional forces which work to tear them down. Erosion is at work while the mountains are being uplifted and long after, until the mountains are reduced to low hills and plains. The rugged topography of a mountain range is the product of erosion. The basins adjacent to an eroding mountain range are filled with sediments which are buried and turned into sedimentary rock. The early Cenozoic uplift of the Rocky Mountains of Colorado provides an example. As the uplift was occurring, some 10,000 feet of mostly Mesozoic sedimentary strata were removed by erosion over the core of the mountain range and spread as sand and clays across the Great Plains to the east. This mass of rock was removed as the range was actively undergoing uplift. The removal of such a mass from the core of the range most likely caused further uplift as the region adjusted isostatically in response to the removed weight. Extraterrestrial mountains on other planets and natural satellites of the Solar System are often isolated and formed mainly by processes such as impacts, though there are examples of mountain ranges somewhat similar to those on Earth. Saturn's moon Titan and Pluto, in particular, exhibit large mountain ranges in chains composed mainly of ices rather than rock. Examples include the Mithra Montes and Doom Mons on Titan, and Norgay Montes and Hillary Montes on Pluto. Some terrestrial planets other than Earth also exhibit rocky mountain ranges, such as Maxwell Montes on Venus, taller than any on Earth, and Tartarus Montes on Mars. Jupiter's moon Io has mountain ranges formed from tectonic processes including Boussole Montes, Dorian Montes, Hyarca Montes and Euboea Montes.